Hello everyone. Today in this video we are going to derive the expression for magnetic field due to an infinitely long conductor. In order to derive the expression, we will use Biot-Savart law, which states that the magnetic field due to a conductor is directly proportional to the current flowing through the conductor, proportional to the length of the conductor, proportional to the angle between current element and the position vector of the point, and inversely proportional to the square of the distance of the point from the conductor. So this is the diagram for the derivation. So I am considering a wire XY in which current I is flowing. I am considering one current element dl, and P is the point where we are finding the magnetic field, and the distance of point P from the current element is R, and QP is the perpendicular distance of point P from the conductor, and A is the distance PQ, and phi is the angle between PQ and PO, and L is the distance of current element from point Q. So according to Biot-Savart law, I can write this: dB is equal to mu naught by 4 pi I dl sin theta by r square. Now I have to put the values of dl sin theta and r square in terms of A and phi. So in this triangle, so this is 90 degree and sum of these two must be 90 degree, because total sum of total angle is 180 degree. So theta plus phi is 90 degree, so I can write theta is equal to 90 minus phi. So if you take sin theta, now if you put the value of theta, that is 90 minus phi, so sin 90 minus phi is cos phi. So instead of sin theta I can write cos phi. So I got the value for sin theta. Now let's do for r square. So again in the same triangle, cos phi is base by hypotenuse. So base is A and hypotenuse is R. So R is A by cos phi. So 1 by cos phi can be written as sec phi. So R is equal to A sec phi. So instead of R I can use A sec phi. Now let's find the value of dl. So again in the same triangle, tan phi can be written as perpendicular by base. So perpendicular is L and base is A. So L is equal to A tan phi. So I'll differentiate this now. So I'm differentiating both sides. So dl, so differentiation of L is dl is equal to A is constant, and differentiation of tan phi is sec square phi, and differentiation of phi is d phi. So instead of dl I can use this. Now I got the value for all the variables. So for sin theta I can use cos phi, for r I can use A sec phi, and for dl I can use A sec square phi d phi. So let's take the equation again. So this is the Biot-Savart law. So I'm putting the values. So if you solve this, you'll get dB is equal to mu naught I cos phi by 4 pi A d phi. So now to get the total magnetic field, I have to integrate from here to here, and for this side the value of phi is negative, so I'll write minus phi 1. So from here to here is angle minus phi 1, and from here to here is phi 2. So I'll integrate this phi from minus phi 1 to plus phi 2. So this is the integration. So all these things are constant, only cos phi is the variable, so I can leave this like integration of cos phi d phi, and integration of cos phi is sin phi. So if you put the limit, then you'll get sin phi 2 minus sin minus phi 1, but sin minus theta is minus sin theta, so you can use this identity. So if you use this identity, you will get the final expression to be mu naught I by 4 pi a sine phi 2 plus phi 1. So if you put this as minus, then minus minus will become plus. If the length of the conductor is small, this angle phi 1 and phi 2 will be small. And if you start increasing the length, the angle will start increasing, as you can see. So previously it was small, now it is increasing. If you take long length, then the angle will keep on increasing. So this way. So if you make this wire to be infinite, this angle will become 90 degree. So for infinitely long wire, the value of phi 1 and phi 2 will be 90 degree. They will be just straight if the wire is very long. So you can put the values now. So for sine phi 1 and phi 2, you can write 90 degree, and sine 90 is 1. So you will get 1 plus 1 is equal to 2. And if you put the value and if you cancel with this, you will get total magnetic field to be B is equal to mu naught I by 2 pi a. So this is the magnetic field due to an infinitely long wire.